In this video, we're going to take a look at exam revision for 2D vectors. So what we're going to do here is just work through some exam style questions for 2D vectors. So this is the first year of material for vectors. As always, pause the video, have a look at the questions as they appear, and double check that your solution matches what we get on the screen. So other than that, I think that's everything that we need here to get started. So let's begin then with question 1. With question 1 here, we've been given the point A, which has position vector of I minus 2j, and the point B, which has position vector of 2i plus 5j. So for the first part here, part A, we simply have to find the vector AB. So for the vector AB here, well, this would simply be the position vector of B minus the position vector of A. And if you're not sure why that works, I think a simple diagram here really helps illustrate this idea. So these position vectors are from a fixed point, which we'll just call the origin here, so relative to a fixed point. So for the origin here, O. So for the point A then, this has position vector of I minus 2j. So I minus 2j, let's say that's here. That's that vector there. Okay. That's I minus 2j. So that's from my point O here, my fixed origin, to A. That's OA. Now we do the same here with the point B. That's position vector of 2i plus 5j. That would be, say, here. Okay, it don't have to be a perfect diagram, but just kind of help illustrate the idea. It looks something like this. That's 2i plus 5j. Okay, and that's for B there. This would be the vector OB. So in this case here, then, what we're actually looking for is the vector AB. So that's from A to B. So from A to B, that's what we're looking for. Okay, not perfect, but that's what we're looking for here. So how do we get from A to B? Well, to get from A to B, I need to go this way. So obviously OA is going in this direction. So if we're going this way, we're in the opposite direction. That would be minus the vector OA. It's going to be minus the vector OA. And then we go from O to B. Obviously we're in that direction anyway, so that would be positive. So it's going to be plus the vector OB there. Okay. But in this case then, this gives us exactly what we've just said. That's the position vector of B minus the position vector of A. Okay. But in that case then, what I've got here is 2i plus 5j. That's the position vector of B. And then we subtract the position vector of A. So it's going to be minus I minus 2j. Like so. Well, in this case then, 2i minus I. That would simply give me I there. And then 5j minus 2j. Just be very careful with the signs here. If I've got 5j and I minus 2j, or I subtract minus 2j, and that would give me plus 7j. It's positive in this case. Okay, so plus 7j there. Okay, so that's the vector AB there. That's the first part done. Hopefully nice and straightforward there. So then for B here, just a quick follow-on part. It says find the magnitude of the vector AB. So remember these two bars here, this just represents the magnitude. So it also says give your answer as a simplified surd. But in this case here then, for the magnitude of the vector AB, so for the magnitude of the vector AB, well, remember this is just simply an application of Pythagoras. So we take the square root here. In this case, we square the coefficients here of our components. So I here, we don't write, but there's a 1 in front of that. So it's going to be 1 squared. And then we add the square of this coefficient here of my j component. That would be plus 7 squared. So we simplify this here. Well, 1 squared is 1. 7 squared is 49. So I get the square root of 1 plus 49 there. That gives us the square root of 50. I get the square root of 50 there, but we need to give the answer as a simplified surd, so we're not done here. So if we just simplify this here, I can write this as the square root of 25 times the square root of 2, and the square root of 25 simplifies to give us 5. It's the same thing as 5, so in this case here, we simply get 5 root 2 there. Okay, and there we have it. That's our answer there as a simplified surd. So that's the solution to A, and that's the solution to B there, giving us a solution to question 1. Taking a look now at question 2 here, so we're given the vector AB, which is equal to 5i plus 12j. We've got 2 parts here again, so let's begin with part A then. So for part A, we have to find the magnitude of the vector AB. Remember, to find the magnitude of a vector, we simply use Pythagoras. So the magnitude of the vector AB here, like I said, we're simply using Pythagoras. It's going to be the square root then. And what we do here is we square the coefficients of our components. So 5 squared plus 12 squared. We've got 5 squared plus 12 squared. And you might actually recognize this here as a Pythagorean triple. So our magnitude here will be an integer value. So in this case then, 5 squared is 25. So the square root here of 25. 12 squared is 144. So 25 plus 144. If we simplify this then, I get the square root of 169. And that is equal to 13 there. Okay, so the magnitude here of the vector AB is simply 13. Just write that down here. Like so. There we have it. So that's the solution there to part A. So now let's move on to part B then. So it's a hence or otherwise part here. So that would suggest that we need to use our answer in part A to answer part B. So we're asked to find a unit vector in the direction of the vector AB. So to find a unit vector, you need to be familiar with how to do this. So for a unit vector, what we do here is we take the vector that we're looking for in that direction. So if we're looking for a unit vector in the direction of the vector AB, then we take the vector AB. We take the vector AB. And what we do is we divide that by the size, or in other words, the magnitude of that vector. So we divide that then by the magnitude of the vector AB. And the reason this is a hence or otherwise is because we've already calculated this. Okay, we did it in part A, and we found that the magnitude of the vector AB is simply 13. So setting this up then, what I get here then is 5i plus 12j. So 5i plus 12j, we divide that by the magnitude, which is 13. So there's a couple of different ways here that you can present the final solution. One way would be to split these components up, so you could write that then as 5 over 13i, like so, plus 12 over 13j. Like that would be one way to present the solution. But slightly more, or a slightly neater way of presenting the solution here would be to factor out the 1 over 13. I could write this then as 1 over 13 times 5i plus 12j. Like so there. Okay. Either of these solutions here is absolutely fine. It's just a different way of expressing the solution. The bottom way here is a slightly neater way of doing that. Okay. But there we have it. So that's the solution to part A there. That gives the solution to part B and the solution to question 2. Moving on to question 3 then, where we're given that the magnitude of the vector AI plus kj is equal to 4 root 5. We're simply asked to find the value of k. So how do we answer this question here? Well, let's use the formula then for the magnitude of a vector. We know that the magnitude of a vector is the square root here then of the square of the coefficient of our component. So that's going to be 8 squared plus k squared. We take the square root then, like we said here, of 8 squared plus k squared. Like so. And we know that this is equal to 4 root 5. Okay. What we're simply looking to do here is find the value of k. So I need to solve this here now for k. So how do we do that? Well, the first thing that I can do here is square both sides. I want to get rid of this square root here. If I square both sides, I'm going to simply get left with everything underneath the square root here on the left-hand side. I'm going to get 8 squared plus k squared. On the right-hand side here, obviously make sure we square both sides of our equation here. So 4 root 5 times 4 root 5. Well, 4 times 4 is 16. Root 5 times root 5 would give me 5. And then we need to multiply 16 by 5. So 16 times 5 would give me 80 there. Okay. So from here now, pretty straightforward, just a matter of basically rearranging, solving for k. So 8 squared is 64. So I've got k squared plus 64 here. And that is equal to 80. Subtract 64 here off both sides. So I get k squared equal to 80 minus 64. So that would give me 16 there. Then from here, hopefully nice and straightforward, I'm just going to take the square root then of both sides here. So that will simply give me k on the left hand side. On the right hand side here, if you take the square root of 16, that would give us 4, but make sure we include the negative solution here as well. So it's going to be plus or minus 4 in this case. So plus or minus 4 there. Okay. It's important that you do include the negative solution here. It's not just positive 4. We do include minus 4 as well. Obviously, if you choose k here to be minus 4, you can test that, find the magnitude of that. And you'll find you do get 4 root 5 there. Okay. But there we have it. So k is equal to plus or minus 4. And that gives us the solution there to question 3. Taking a look now at question 4 here. So we've got a particle that's moving with velocity of 4i plus 3j meters per second along a straight line. We've got 2 parts here, so let's begin with part A then. So for part A, we have to find the speed of the particle. So this question here might seem a little bit odd because this is a question involving some very basic, level of mechanics here. And obviously, the 2D vectors that we're looking at are for the pure part of the course, but it is something that you are expected to be able to work with. So even though it's pure, you might get a little bit of mechanics in this. But like I said, it's very basic, nothing too challenging. But in this case here, for example, you need to be aware that the speed of a particle in this case is equal to the magnitude of the velocity vector. Very basic, but obviously if you're not familiar with that concept, then you're not going to be able to answer part A. So for the speed then, like we said, that's the magnitude of the velocity vector. So what I'm going to do, I'm going to write that down here. We've got a note of it. So speed is equal to the magnitude. The magnitude of the velocity vector. Remember here, finding the magnitude, we've already done a few examples of this now, nice and straightforward. We simply use Pythagoras. So in this case then, speed here, that would be the magnitude of our velocity vector, which we've got here, 4i plus 3j. We take the square root then. And what we do here is we square the coefficients of our components. It's going to be 4 squared plus 3 squared. 4 squared plus 3 squared. So again, hopefully you might recognize this here as a Pythagorean triple. This would be the square root of 16 plus 9. That would give me the square root of 25. Hopefully you recognize straight away as 5. Okay, so the speed here of the particle is 5. Don't forget the units, it's not just 5. In this case, it would be 5 meters per second as well. Okay, so ms, the -1 there. Okay, and there we have it. So that's the solution to part A. That gives us the speed of the particle. Again, hopefully nice and straightforward. It's just being aware of this concept then, that the speed is equal to the magnitude of the velocity vector. Okay, so that's part A done. Let's take a look now at part B here. So for part B then, it says find the distance travelled by the particle, and it has been moving for 8 seconds. Let's just go back to some kind of basic GCSE maths here and working with compound measures. So in this case then, the distance here, the distance is equal to the speed of the particle in this case, equal to the speed multiplied by the time that it's been traveling for or moving for, which in this case would be 8 seconds. So it's speed multiplied by time. So the speed of the particle, we work that out in part A, so we don't obviously need to work that out again. We've already got it, so that would be 5. Then times that by the time that's been traveling for. So you're given that in the the question here, part B, we're told it's been moving for 8 seconds, so I times it by 8. We get 5 times 8, nice and straightforward. That would give us 40. And again, don't forget your units here. So the velocity here, the velocity vector, 4i plus 3j meters per second. We're working in meters here for the distance, so 40m there. And there we have it. So that's the solution to part A, and that's the solution to part B there, giving us a solution to question 4. Moving on to question 5 now, where we've been given three forces, F1, F2, and F3. And these three forces, F1, F2, and F3, are acting on an object, and they're given by the following vectors. So you can see F1 here is equal to I minus j newtons, F2 is 3I plus j newtons, and finally F3 is 2I minus 5j newtons. So for this question, we're asked to find the resultant force of F1, F2, and F3. So again, it might look a little bit odd, a mechanics type question within the pure part, but again, it's just something that you are expected to be able to do. So remember, for a resultant force, so let's say we've got these three forces here, F1, F2, and F3. The resultant force would simply be the sum of these three forces. So we normally use R to represent a resultant force, so I'm going to call this R here. So R is equal to F1 plus F2 plus F3. So let's just show that here. Got F1 plus F2 plus F3. Okay, so like we said, resultant force is simply the sum of the individual forces. Okay, so this should hopefully be nice and straightforward. But in this case then, R is going to be equal. So F1, that's I minus j newtons. So I've got I minus j. Like so. What I'll do is I'll just put in brackets just to kind of separate them, just so it's clear which, which each individual force is. So F1, I minus j. F2 here, that's going to be 3i plus j. 3i plus j there. That's F2. And then finally for F3 here, that's going to be 2i minus 5j. So again, this in brackets just so we can split them up nicely. I've got 2i minus 5j there. So in this case then, we're simply adding these three vectors together here. So add the I components together separately, do the same with the j components. Should all be hopefully nice and straightforward. So I plus 3i plus 2i, well I plus 3i is 4i, plus 2i there, that would give me 6i. I get 6i there. I've then got minus j plus positive j here. So they'll just cancel, will give me 0. And then I add minus 5j, which is just the same as subtracting 5j. So in that case then, we get 6i minus 5j. Now, this is a resultant force, so don't forget we need newtons here. So this is for the resultant force, R. You don't have to call this R, but typically we would for a resultant force. You just use R to represent that. I've got 6i minus 5j newtons there. Okay. And there we have it. So like you can see, nothing too challenging, especially in terms of the mechanics type questions here. But it's just understanding these basic principles, such as the resultant force being the sum of the individual forces there. Okay. But there we have it. So that's the solution there to question 5. And finally then, if we take a look here at the very last question, question 6, where we're being given three column vectors. So I've got the vector A, which is equal to m2n. I've got the vector B, which is equal to n4m. And finally, the last column vector here, C, which is equal to 3, 4. And we're also given that A plus B is equal to C. We're asked to find the values of M and N. So I've included this question here just to show you that obviously we can have our vectors here being represented as column vectors. So rather than using the IJ component notation, we can also represent them as column vectors like you can see here. Nothing different though, just the same principles that we've been using for the previous few videos and within this video. So where do we begin here? Well, let's use this addition here of the vectors. So the vector A plus the vector B is equal to the vector C. So we just use the column vector notation here just to get started. We've got M, 2n, plus this vector here, this column vector, so n, 4m. That is equal to 3, 4. Remember, when we're adding vectors like this, if it's in column vector notation, it would be m plus n is equal to 3. I can set up two equations here. So my first equation would be m plus n equal to 3. So m plus n is equal to 3. Then my second equation here would be 2n plus 4m is equal to 4. We've got 2n plus 4m is equal to 4. And what we formed here is some simultaneous equations. And all we're going to do here is solve these simultaneous equations, and that will give us the value of m and the value of n. So to begin with then, It's up to you which way you use to solve these simultaneous equations, whether you use substitution or elimination, for example. What I'm going to do here, though, is simply use substitution. I'm going to rearrange here to make n the subject. No matter whether you make m or n the subject, obviously. I just chose n in this case, but like I said, honestly, it doesn't matter. So in this case, then, n is equal to 3 minus m, like so. What I'm going to do now is take this n here, which is equal to 3 minus m, substitute that into equation 2. So that's equation 1. This is equation 2. Okay. But this should hopefully be nice and straightforward, just solving these simultaneous equations. Again, it's just basic GCSE math. So, substituting n now into equation 2 here, we get 2 lots of 3 minus m plus 4m, and that is equal to 4. And what you can see here now is we've got this equation then just in terms of m. So we've eliminated the n here in equation 2. So 2 times 3 is 6. 2 times minus m would give me minus 2m. Expanding that bracket, we've got plus 4m. And that's equal to 4. So if we simplify this here and just solve for m, well, minus 2m plus 4m, that gives me 2m. I've got the plus 6 here, so 2m plus 6. That is equal to 4. So from here now, subtract 6 off both sides. I get 2m equal to minus 2. And then finally, if I divide both sides by 2, I get m equals minus 1. But we're not done here. Don't forget we do need the value of n as well. But that's nice and straightforward using our rearranged form here. So in that case then, n is equal to 3 minus m. If m is minus 1, we've got 3 minus 1, which is the same as 3 plus 1, giving us 4 there for the value of m. Okay? And there we have it. So you can see the value of m there is minus 1. The value of n is equal to 4. And there we have it. So that gives the solution there to question 6. That brings us to the end of this video on exam revision for 2D vectors.